Dean and Gavin, hey, we went ahead and did a quick quiz in the back of our spirals, the workspace. They spent about 5-ish minutes on it, and I went ahead and did the multiple choice on the back board. You guys can slide open the board to see the answers if you need to. They should still be there both today and tomorrow. However, right now we're going to go over the free response. So pause the video if you guys haven't tried it yet in your workspace. Trying a quick quiz to see how you do. All right, free response. Let's talk about it. Ooh, the screen is frozen. So yes, you guys do have a test review, so if you're totally bored, you could be, I suppose, working on the test review. But we're going to go over the free response and see how you guys did as quickly as possible. So f of 3, easy cheesy, right? All we got to do is plug in. So f of 3 ended up equaling what? Negative 3. Good. 6 minus 9. F of 3 plus h. Do you guys see how we're building the definition of the derivative? Did you carefully distribute the 2 and carefully, oops, that's not right, square the 3 plus h and distribute the negative? If so, you guys should have gotten 6 plus 2h minus 9 minus 6h and minus h squared, which should have reduced down to, what do we got? Negative h squared. I don't like that. We can do it the awkward way. Is that all right? So we have negative 3 minus 4h minus h squared. You guys good? Mm-hmm. Sweet. And then for letter C, we need to go ahead and build the difference quotient. And all of this, remember, they didn't know how to do derivatives, true? In this textbook at this point and at this time. So then you can go ahead and plug in what we just found, and we end up with negative 3 minus 4h minus h squared minus negative 3, hence plus 3, all over h. At which point we can simplify. We can reduce an h because everybody's got it, but I'm going to show the legal work because some of you do a lot of illegal stuff. We can reduce the h because it factors out, and we end up with the final expression of negative 4 minus h. So far we have negative 3 for A, negative 3 minus 4h minus h squared, or some variation of that for B. We have negative 4 minus h for C. And how do we use that to find the instantaneous rate of change of f at x equals 3? Aren't they asking us to find f prime of 3? Isn't f prime of 3 the same thing as limit as h goes to 0 of f of 3 plus h minus f of 3 all over h? And isn't that what we just found? Yes. The only thing left to do is plug in h is 0. Done. Oop, done. Thank you. Questions? On the limits test, am I going to make you solve this the limit way? Maybe. Probably not. But are you going to need to be able to recognize what this is and how to solve it, even if you don't solve it the limit way? Yes. So what could have been another way of getting to letter D without using the limit definition? What would you guys have done? Derived it. You would have gotten 2 minus 2x, and you would have plugged in 3. And what's 2 minus 2 times 3? 2 minus 6 is negative 4. So you have to be able to recognize, right? So if you're like, it's no big deal, I'm just going to do derivatives the whole test. That's great as long as you recognize a derivative when it comes. Are we tracking? Yeah. Cool. All right, with that, let's go ahead and, we better grade section number 4. Is that our last section? Yeah. Homework number, whatever it is. Here we go. Chapter 2. Let's grade the evens. Remember, you're turning in your notes and your homework spirals tomorrow. Notes need to be fully up to date. I've been absent. I don't care. It's online. Homework needs to be attempted and graded and finished. My ones that sometimes turn in partially attempted homework saying you had questions, it should be answered by the test. True? Good. Number 6, final answer for A is negative 2 over pi. Negative 2 over pi. For B is 0. For A is 2 over pi, and for B is 0. Uh-oh. Is it making sense, or is it confusing? Oops. Okay, moving on to number 10. Number 10, final answer is negative 2 for A. For B, you were supposed to be solving for the tangent line, which, guys, check it. Couldn't you just grade it here and add the 3, y plus 3 equals negative 2, x minus 1, or you could have simplified it, I suppose. Up to you. Letter C, what did normal mean? Latin, normalis, normalis, perpendicular. Perpendicular has what kind of slope? Opposite reciprocal. Y minus y1 equals n times x minus x1. You should have flipped the -2 and made it a positive 1/2. Here's your point slope, right? If you just add the 3. And then you're supposed to graph it and say, hey, look, it's tangent. Hey, look, it's perpendicular. Awesome. And if you graphed yours and it wasn't, well, something went wrong. Number 30. Final answer is 16 pi, the meaning of which was dV dr. dV dr. The volume is changing at a rate of 16 pi inches cubed per inch. That is 16 pi cubic inches of volume per inch of radius. It's how the volume is changing with respect to the radius changing. As the radius changes, how does the volume change? As you blow up a balloon and as the radius gets bigger, how does the volume change? Number 42 is false, because the slope is undefined, true? Number 44 is E. Number 44 is E. Sorry, it's still up there, my bad. E. Number 50 has a cusp, aka a vertical tangent. Has a cusp. Oh, it doesn't actually say that, sorry. Vertical tangent. We must not have talked about that yet. It's a vertical tangent because the limit of the derivative is infinity. The number over 0 when you try to plug in. You might have seen that better with a limit than you would have with a derivative. Number 52. Number 52 is a no. There is not a vertical tangent line. There is not a vertical tangent line. Long story short, if you were to solve for the limit, from one side, the limit of your slopes or of your tangents would be negative infinity. From the other side, also negative infinity. However, the original graph negative infinity. Negative infinity. Hold on. The left hand, right hand limits are negative and positive? What am I not considering? Oh, this is the derivative. Sorry. This is the derivative. My bad. They don't agree, so therefore the limit does not exist. That's not a vertical tangent. My bad. I thought that was the original function. It's not. It's the derivative function. And then we're done. And then we're done. We're going to go back to homework questions in just 1 second. Some of you guys might still be grading those homework questions. Did anybody notice in Google Classroom that I posted the review? Yeah. Okay. What's different about CalcBC reviews? What did you guys notice when I posted that? Or did you even look at it yet? Sorry. It's right here. When you open the review, what do you see? Ooh, what's this? Here's something kind of snazzy. You have the odds and evens. Why did I give you that? Oh, wait a minute. Hold on. These aren't the answers. These are the... Because sometimes we're going to have a work day on review day, and how many people actually bring their books to class? No. Now, Joe, you're totally fine. But I go ahead and post it on Google Classroom because then you can just grab out your phone, open it on Google Classroom, or maybe give the poor person who doesn't bring their phone to class the book. But everybody else can go ahead and access on Google Classroom the questions, work on it, but what's after the questions? The answers to the evens, because the odds are in the back of the book. Sound good? Yeah. Wowzers. So is that kind of cool? We're going to go ahead and some of you are working on the review. Some of you would like to be working on the review, but I only had one extra book. Now you can. The rest of you guys, are there any homework questions? I have my webcam open and ready to go. But you guys want to see from section 2.4. Janelle? 15. Anything else besides 15? Jacob? 37. Let's start with those two. If we have more, we'll go to them after that. So number 15, first of all.
Miss C, can I get my homework book?
Yes. Alright, number 15 is asking whether or not the curve has a tangent at the indicated point. It will have a tangent if the slope exists. Pause. I'm letting some of you open your phones, open your Google Classroom, work on what is productive to you, but do not steal my time, aka shush. Okay, number 15. Determine whether the curve has a tangent at the indicated point. So we're trying to basically ask, does the derivative exist in your guys' terminology from what you understand? The derivative will... Why is that so dark? The derivative will exist if the limit of the difference quotient exists. And the limit of the difference quotient will exist. Sorry, I'm making the lighting a little bit better. If the two-sided limit, or I should say the one-sided limits agree. My bad. Okay, there we go. Oh my goodness. 10 years later. Okay. So therefore, most of you guys are not actually doing the limit of the difference quotient, but if you were doing the limit of the difference quotient, that's kind of hard to see. I think it might be easier if we do, just ignore that. Okay. It'd probably be easier if we did this version, which is x going to 0, and then limit as x goes to 0 of f of x minus f of 0 all over x minus 0. If you want to see why this doesn't work, this is technically what you would be doing, taking the limit from below and above when finding the derivative. It's a variation of the difference quotient. Because then you could go ahead and see if I'm coming from below, I'd be using the below piece, and if you're coming from above, you'd be using the above piece. So in this one, I'd be using the limit as x approaches 0 of this f of x, which would be 2 minus 2x minus x squared, minus f of 0 is literally where or when x equals 0 or equal to 0. What's the value? So 0 plus 2 would be 2. Which this one, those would cancel. My x's would reduce, and we'd end up with negative 2 minus 0, which is negative 2. But for this bottom piece, if I'm approaching from above, I'm using the other portion. So now I'm doing the limit as x approaches 0 from above, which will be of 2x plus 2. My f of 2 is still the same, which once those reduce, the x is reduced, and then rut-row. But what's true about these two?
No.
Negative 2 does not equal 2. Now, this is using the difference quotient, but didn't I say technically that you can be finding derivatives? But how do we find derivatives of a piecewise function? Piece by piece. What's the derivative of the top? What's the derivative of the bottom? Why am I not saying at 0? Because I don't know. They have to agree from either side for that limit to exist. So what would be the limit as x approaches 0 from below and the limit as x approaches 0 from above of my derivative? To be differentiable, these have to agree. If I come from below, aren't I going to plug in 0, negative 2? And if I come from above, aren't I going to get 2? The exact same results as up here. They're not agreeing, so my limit is not existing, which means that my derivative is coming together at a sharp point. Does that make sense? It's coming together at a sharp point because those limits aren't agreeing. The limits of the slopes, or I should say the slopes themselves aren't agreeing. Now that was number 15. I'm so sorry, I forgot. We had another question. What was it? Jacob. 37. Thank you, thank you. Sensitivity. Now for sensitivity, remember that we had that little piece of information from yesterday as far as how to find sensitivity. And sensitivity is basically T prime of D. T prime of D. Or you could think of it as delta D over delta T No, my bad, I did it. T prime of D. Delta T over delta D as delta D goes to 0. We're trying to figure out when the dosage is 2 milligrams. How the temperature will change with respect to, or how fast, basically the rate of change of temperature with respect to dosage. So the nice thing is the shortcut for us, because we know derivatives, is basically T prime of D. So when it says find and interpret the sensitivity of the patient's temperature to the dosage when when D equals 2, I'm finding this such that D is 2. So the nice thing is if we can rewrite this in a nice way, I get 99 plus 4 over 1 plus D by T prime. Since we know derivatives, derivative of any constant is going to be 0, right?
Yeah.
This, it would have been way easier to think of it as a chain rule, where I bring down my -1. Now I'm going to have 1 plus D to the -2, and then technically times U prime, but that's just 1. So then my T prime of 2 would be -4 all over 1 plus D would be 1 plus 2 squared, which would be -4 over 9. And then the interpretation, what is this saying? It's the rate of change of temperature with respect to dosage when the dosage equals 2. But we could put that all together and be all snazzy by saying, okay, temperature, I believe, is degrees Fahrenheit with respect to milligrams. So you can say when the dosage is 2 milligrams of whatever medicine we're talking about, the patient's temperature should be decreasing because of that negative rate, right? At a rate of 4/9 degree Fahrenheit, or you could say 4/9 degree Fahrenheit per milligram. Or you can put per milligram, either way. I kind of like the 4/9 degree Fahrenheit per 1 milligram change, but that's great. Is that good, Jacob?
Yeah, that's good.
Cool. Anything else? We did 15. We did 37. Any other homework questions? Going once, going twice, and sold. I see almost everyone working on their review. I'm a fan. Hey guys, can you remind me real fast, why am I still requiring the review even though we have some practice AP multiple choice on AP Classroom? Yeah, on AP Classroom it has nothing to do with our curriculum, and your test is coming from your curriculum. So the AP Classroom is to help you in preparation for the AP test on these types of topics, but the review in your book is to help you specifically for the test tomorrow. So that's why AP Classroom is not due until basically midnight, 11:30. Good deal? So you could choose to do it after the test if you would like, but I think it would be most ideal to do it before the test. I'm going to pass out summer packets just because they've been kind of cluttering my life and they've been graded for a while, and I'll be available for questions if you guys have it. Let me put up on the screen in case someone doesn't have their phone and there's no book to go around. Oh, just kidding. The beginning of the review, at least, because you guys have 1 through 20 all. Woo-hoo-hoo. Wait, but it's a review. If it's a review, what don't you have to do? You don't have to write the directions or the problems, right? Go team.
For number 11, when it said int, is that integer? Or what?
That's the greatest integer function, aka the step function. You know what I mean? You're not getting your summer packet back right now. It might be because I never got it. With a 0 in your grade already? Hi. Just so. back there?
I have a photo.
Oh, I only got partway through. I'm lame. Next time you're supposed to be able to hear about
Okay, so height is the same. Height is the same. Initial.
Oh, yeah.
And you should just put down don't do that, so it's not what it is. Instead I would keep these there because then you end up with H prime or 15, 16.
But you put
Yeah, or 8%. Now it's changed my routine next. It'd be P, so it'd be height DH over 8%. So the umbilical feet per second, so it's talking about the rate of change of height with respect to velocity. So height is increasing at a rate of 15/16 feet. Or feet per second change of velocity. That makes sense. So height is increasing at a rate
But as okay. Oh yes,
P.S. Should you guys have your review graded if I have the evens online?
I'm gonna freeze the screen and try to get in the rest of the review, because I didn't mean to have the partial review in there. That's kind of annoying.
1 over e to the x, so it's either way it's
John, do you have a question?
no,
Oh,
so
okay.